Hi, everybody, and welcome back to TGCS. My name is Tim Gallagher, and we are continuing our video series to get you ready for the 2026 AP Computer Science A exam. So today we are going to do a crash course in Unit 4. And in fact, this unit is so large, data collections, we're going to have to break it up into two parts. So this first part, we're going to focus on data sets, arrays, file IO, and array lists. All right, let's get started. So here are the first 10 sections of Unit 4. As you can see, it talks about data collection first, and then arrays and array algorithms. We'll get into using text files, and then finally array list and the different array list algorithms that we will need to develop and that you might see on the exam itself. So let's first start talking about the ethical and social issues around data collection. And these are some of the things that we're going to discuss. We'll talk about how does computing impact our society and our economy and our culture? What are the risks to personal privacy when using a computer? What is algorithmic bias and why is that important to us? What biases might exist when data is collection? Should you worry about incomplete or inaccurate data? Is that a problem? And of course, why is it important to use appropriate data to answer our questions? So here we discuss some of the ways that computing can impact society, economy, and culture. And we have different areas of each of those listed here. And for the AP exam, just be familiar with the different ways that computing can affect these different areas. Here within society, economy, and culture, we have listed some positive impacts and then some challenges that we face as computing grows and AI becomes more prevalent in our society as well. Things that you should be familiar with in all different areas of computing, society, economy, and culture. All right, let's talk about personal privacy risk, right? Is your personal information at risk? Think about granting apps access to your contact personal information or your location. What can they do with that data? What should be some of the considerations that you as a programmer need to be worried about when you are writing your software and collecting that information? Only collect necessary information because you don't want to put your customers or your friends' data at risk by storing it and storing information that you don't necessarily need and maybe being careless with that information as well. So algorithmic biases, when writing programs, a system might work differently for one group of people compared to another group based on the information that it gathers and the conclusions that it makes based on that information. And an algorithmic bias is what we call a systemic and repeated errors in a program that create unfair outcomes for a certain group of users. And you should be concerned about this. And really, when writing software, attempt to overcome these biases so that your computer program is fair and works the same for everybody. Now, when we collect data, there could be some biases too. Maybe you only looked at a particular subgroup of people, whether it's a certain age or a certain location or a certain ethnicity. And will this type of data collection maybe affect some of the results or the conclusions that you're making with your program? Does the biased data affect the reliability of your software as well? And can you extrapolate new information or draw conclusions based on biased data? Well, that's kind of difficult because if your data only pertains to a certain subgroup and you make some extrapolations based on that data, those conclusions might not be correct because you didn't take in the larger population as a whole. So consider if your data is incomplete or inaccurate. If you have incomplete or inaccurate data, then maybe your conclusions can't be trusted. Your data, maybe it should be validated to make sure that it's truthful and that it represents the population that you've gathered the data on as well. Also, sometimes data might need to be cleaned. Maybe you want to get rid of the extraneous information or get rid of some of the data that might cause a privacy risk or get rid of information that doesn't really pertain to the software problem that you're trying to solve. Therefore, knowing your data and what it represents can really help guide your decisions on how that data should be used. Data related to a specific question or topic might not be appropriate to give correct information or maybe make an extrapolation about a different question or topic. One question here is, would you survey the entire school to make decisions about senior class activities or vice versa? You might not just survey the senior class to make decisions about the entire school. And also, what about the age of data? Older data might not be as useful when making decisions about current problems or current situations. So again, think about the appropriate use of your data and how they could be used to help draw appropriate conclusions. Now, let's talk about data sets. Once we've collected all this data, a data set is a collection of specific pieces of information. And in our programs, we can manipulate that data and analyze that data, maybe to answer a question or solve a problem. And this data can be represented in tables and charts, lots of different ways to have that data presented. Hey, here's our first sample multiple choice question right from the CED, and it's about data sets. So let's take a look here. It says a researcher wants to investigate which age group, under 18, 18 years old, or 18 and over, is more likely to have downloaded a certain application from an online store. Now, each customer of the store has a unique ID number. The researcher has the following data sets available. So dataset 1 contains an entry for each application available from the store, and each entry includes the name of the application and the total number of customers who have downloaded it. Dataset 2 contains an entry for each application available from the store. Each entry includes the ID number and the age of the customer who most recently downloaded the application. Dataset 3 contains an entry for each customer of the store, and each entry includes the customer's ID number and the customer's age. Dataset 4 contains an entry for each customer of the store, and each entry includes the customer's ID number and the names of all the applications downloaded by that customer. Now, that's a lot of information, but remember, we're looking to see which age group is more likely to have downloaded a certain application from the store. Based on those datasets, which two datasets can be combined and analyzed to determine the desired information? What do you think? Well, if you said D, datasets 3 and 4, that would be correct, because dataset 3 contains an entry for each customer, and that includes their age, and then dataset 4 is an entry for each customer and includes the names of all the applications that they downloaded as well. So by combining those two, we can see which age group might have been more likely to have downloaded that certain application. Okay, let's talk about data structures, because that's really what a lot of Unit 4 is all about here. Why do we need them? Well, if you want to store a large number of values or strings or any other object, we can't just have individual variables for all of them. That'd be way too many variables, right? So especially if we don't know how many we need to keep track of. So a data structure is going to be our format for organizing, storing, and accessing our data in a computer efficiently and concisely. Now, the first data structure that we're going to look at here is an array, and it's used to store our collection of values. An array is one type of data structure, and it's really an extension of our primitive types. A one-dimensional array, or it's also called a 1D array or just an array, is a fixed length list of values with the same type, which can be an object or a primitive type. And here's an example. I can have an array of ints called numbers equals new int, and I put 10 in the bracket. This creates an array of size 10, which is numbers is the name of the array, and it can store 10 integers. Now you'll notice that even though we have 10 elements, they're numbered 0 through 9, and that has to do with the offset. And the first location has an offset of 0, second has an offset of 1. So just understand that these are all numbered starting at 0 up to the number of boxes minus 1. So from 0 to 9 for a list of 10 elements. Now, here's a representation of what our array looks like stored in memory. So again, I declared it by saying int bracket numbers equals new int bracket 10. So I know I'm creating an array of integers of size 10 because I put the 10 in the second set of brackets, and I use the new int to construct this array. And now numbers is a reference variable that holds the address of where this array is. Now, by default, the elements of local arrays of integers or doubles are initialized to 0, and the arrays of objects are going to be initialized to null. Another way of creating an array is to use an initializer list. So here I have an array of strings called states, and I put in a number of states into my array by using the curly braces, and by just listing the values that I want to have inside the array, this automatically constructs an array of the exact size needed to hold that exact amount of elements. So here I've got 8 states listed, and when I put 8 states in my curly braces, I automatically create an array of size 8 that have all of these strings listed in each of the elements of my array. So here's another way I could say double bracket scores. I have 4 numbers listed that are doubles, and it creates an array of doubles called scores. So the length of the array is 8, but remember the elements of the array are numbered 0 through 7. And we can access the length of the array by referring to its length attribute. So if I said system.out.println states.length, it's going to print out 8 because there are 8 elements in the array that I declared. All right, your turn. Real quick, looking at these, which of the following are valid ways to create an array? Let's choose all that are correct. If you want to pause here and give it a shot, and we'll come back and look at the answers. Ready? Okay, it is these. So the first one's wrong because it says new array. We don't have anything that says new array. The second one creates an array of size 7 of Booleans called decisions. This third one creates an array of strings called fruit, and it's of size 4 because I put 4 fruit strings in the initializer list. Double temps is not valid because I'm using parentheses around my doubles. That should be a set of square brackets. String amounts equals new double. Wait a minute, those types don't match. So I can't do that. The arrays have to be all the same type. And then finally, num days works because I have an array of integers called num days, and you'll notice I have 12 numbers in there. Looks like they represent the number of days in each month. All right, let's keep going. Now let's talk about using arrays. So here I've got a main method. I've declared an array of string called states that is a new string array of size 4. By default, they're all going to be initialized to null because I haven't put anything into my array yet. Here is how we do assignment statements with our array. It is just like assigning variables, but instead of just saying the name of the variable equals the value, I'm going to say the name of the array variable, bracket with a number inside as to indicate which box or which element of the array I'm assigning this value to. So states 0 becomes Florida, states 1 becomes New York, and when I initialize that, 0 becomes Florida, 1 becomes New York. And then when I say to print states 1, what's going to happen? It's going to print New York. And then when I say print states, or I say states 1 equals Texas, and I say print states 1, it's going to print out Texas. When I print out states 3, it prints out null because there is no value in state 3. Oh, but wait a minute. When I say states 4 equals Georgia, what happens? I get an array index out of bounds. Why? Because there is no box 4. So you have to make sure that you don't try to put an element or put a value into an element that doesn't exist. All right, another way you can use two arrays together to represent two sets of collection of data. Here I've got an array of string called names, which is Abigail, Bobby, Sierra, Diego, and Emily. And then I have also an array of integers I'm calling high scores. And I can print out name 0 has a high score 0, and then names 1 has a high score of high scores 1. So these are ways that I can store data in two arrays or parallel arrays. All right, let's talk about traversing arrays now. So we know that if I had this array of states, I could print them out like this, and that works fine. It prints them all out. I've got Florida all the way down to Georgia. But notice I've got these numbers here, and I'm visiting each number. There's got to be a more concise way I can do that. There is. I'm going to use a for loop. So here, rather than print out all the individual print line statements, I'm going to create a for loop that is going to start at 0, keep looping as long as my index, is going to be less than the length of the array, which in this case is 8, and then increment the index by 1 with each iteration. So now I'm going to have a print line statement to say system.out.println states bracket I, and as I loop through all of the elements in my array, it'll print out Florida, Texas, Arizona, Ohio, New York, California, Oregon, and Georgia. Okay, what about going backwards though? Can I loop through the array backwards from Georgia all the way back up to Florida? Well, I can. I can use a for loop, but notice this time I'm going to start at the last element of the array for my index. I'm going to keep looping as long as the index is greater than or equal to 0. And now I'm going to decrement each index by 1 with each iteration. So when I say print out states I, what's going to happen this time? It's going to print out from Georgia all the way down to Florida. And there we go. Now, here's something a little bit different. In this case, I'm going to go back to my forward loop here, and notice I stored each string in a state name, and then I printed out the state name. That works just as it did before. But I want to focus on these two lines right here. These two lines where I'm looping through the index numbers and assigning each element to a state name string before I print it out can be replaced by what we call an enhanced for loop, also called the for each loop. And this reads, for each string state name within the states array, and then I want to print the state name. So here's what my code looks like when I run it. It's going to print out Florida, Texas, Arizona, Ohio, New York, California, Oregon, and Georgia all the way down because of an enhanced for loop can be a shorter or more concise way of coding rather than having to have the entire for loop with their index numbers. All right, so let's compare the two different types of loops we've looked at. Here's my for each loop, and then over here is the equivalent traditional for loop. Now you'll notice that the enhanced for loop has the advantage of less code, and you also can't go out of bounds, because if you're just saying visit every single element in the array, I don't have to worry about saying, is it less than states.length? Is it less than or equal to? I don't have to worry about the index out of bounds exception. The for each loop, the enhanced for loop handles that for me as I visit each element in my array one at a time. So I can't go out of bounds. There are some limitations, however. Remember how I went backwards with a for loop? Yeah, I can't do that with an enhanced for loop. It only traverses forward. Let's talk about populating my arrays now. So here I have an array of doubles called values that is of size 10. I'm going to have a for loop that loops through all the different index values in my values array. And for each element in my array, I'm going to assign a random number. Hey, here's math.random, and I'm going to multiply it by 100. Afterwards, I'm then going to traverse the array once again using that for loop, and I'm going to print out the values that are in the array. So when I run this, notice I've got 10 different random doubles between 0 and 100. And let's do the same thing now with my states array. So here I use an initializer list. So in this case, I'm looping through and I'm going to change each element, states bracket I, to the state Florida. Well, when I run this code, it works. It looks like as I traversed through the array, I printed every single one of the states. I changed every single one of the states to Florida. So when I traverse the array, it prints out Florida for each one of them. Let's try this with a for each loop. So here I say for each state name, for each string state name within states, state name equals Florida. And then when I run the code and try to print out all the states, what happened? They didn't change. Why not? Well, because state name, when I set state name equals to Florida, the original array does not change. So I'm changing the state name string to Florida, but I'm not actually modifying my array. So that's something else to concern yourself with when you are using an enhanced for loop, is that you're not actually going to be able to change the actual elements and the contents of the array itself. Okay, let's talk about implementing array algorithms. Now, on the AP exam, question 3 deals with ArrayList and question 4 deals with 2D arrays, but there could be some 1D array algorithmic issues thrown in there as well too. And of course, on the multiple choice questions, you may have to evaluate or fill in the missing pieces of some simple array algorithms as well. So anytime we are implementing algorithms, we should ask ourselves some questions. What is our goal? Do we need to get a value, a location, or a calculation? What type of results do we want to get? Also, what type of values are in the array? Are they objects? Are they primitive types? And how can we compare, accumulate, or check attributes or the contents? And do we always need to traverse the entire array to complete our algorithm? Under what conditions could we halt our algorithm before traversing everything? So let's look at some different algorithms. First, we're going to talk about computing a sum or average of the elements in the array, determine the number of elements in an array having a particular property, and also determining if at least one element in an array has a particular property. And these are 3 of our more common array algorithms that you should be expected to write and to also interpret if you see them on the AP exam. Let's start off with finding the average of values in an array. Well, what is the algorithm like? So here's my array of numbers. I'm going to have some sort of sum first, because you know that in order to calculate the average, you have to add them all together. So I'm going to traverse my array and add each element in the array to my sum. And as we add all the elements to the sum, looks like I now have 277. How do I calculate the average? Well, I take the sum and I divide it by what? Well, the number of elements, which I know is going to be values.length here. So that's my algorithm. Let's write some code to implement this algorithm. So here I have a method called getAverage, and it looks like it takes in an array of values, and it wants to calculate and return the average of the values in the array. So what do I do? Well, I'm going to have a variable to hold a sum. So int sum equals 0. I have a loop here to traverse all of the values in my array. I add each value to my sum. Notice I'm using values bracket I because I is the index in my for loop. And then after my loop is done, I'm going to return the average by dividing the sum by the number of values in the array. Now notice that we also cast sum as a double first because that allows for decimals in our average. And as you can see in the method header, the average is supposed to be a double anyway. So that makes sense. All right, let's look at the next algorithm. So now let's say I want to find the number of strings that end with a particular letter. Let's go back to my states array that we had all the different states in there. And let's say I want to figure out which states end in the letter A. So how would I do that? Well, I would again traverse my array and I would look at each individual string and count how many of them end with an A. So I have a counter. Florida ends with an A, so that's 1, not Texas. Arizona ends with an A, so my counter is now 2. Ohio does not end with an A. New York doesn't end with an A. California ends with an A, so now my count is 3. Not so much Oregon. And finally, Georgia ends with an A, so my counter is now 4. So that's how I would find the number of strings that are going to end with a particular letter. I'm implementing an algorithm to determine the number of elements that have a particular property within my array. Let's look at the code. All right, so here we have a static method called number of states that end with. And this is going to count and return the number of string in states that ends with a particular letter. And we can assume that letter is a string with a length of 1. So first we're going to need a variable to use as our counter. So we're going to say counter equals 0. Now we're going to traverse our array. Notice we have int I equals 0, I less than states.length, and I plus plus. Okay, now we want to check to see if the current string ends with the letter. And this is a lot. We'll do this by looking at the states bracket I, which is the current state that I have. I'm going to use the substring method and the parameter states I dot length minus 1, which will give us the last letter of our current string, and then use the dot equals method to compare it to letter, which is our parameter. Now, since we used an initializer list for this array, we're going to assume that there are no null values. But that might be something you want to check for, because otherwise, if you try to get a substring of a string that's null, then you're going to get a null pointer exception. So think about that when you're writing the array. Could there possibly, or when you're writing the algorithm, because could there possibly be null values in my array? If we did find a string that contains the particular letter at the end that we're looking for, we're going to increment our counter by saying counter plus plus. And then after the loops have completed, we'll return the total number of states ending in the letter that we found by returning counter. And that's our algorithm. We determined the number of elements in our array that had a particular property. All right, on to the last algorithm in this group. Let's talk about if we want to determine if at least one element in an array has a particular value. So for this example, we're going to look to see if a particular state name exists in our array. So here are my states. Here's the states array. And I want to say if we have a particular name such as New York exist in our array. How would I do that? Well, here's the algorithm. I'm going to traverse my array starting at the first element and see if that's New York. It's not in spot 0. New York's not in position 1. It's not in position 2. It's not in position 3. Hey, position 4 contains New York. I found it. So now once we found the state we're looking for, do we have to keep traversing? Well, no, because this algorithm is a little bit different. And here we can stop traversing immediately because we found what we're looking for. All right, let's put this algorithm into code. So here I've got a static method called containState. It takes in an array of string called states and the target that I'm looking for as well. First, I'm going to traverse the array, and notice here I'm using an enhanced for loop for this solution. It's totally optional, but it's convenient. I know I'm not going to go out of bounds. All right, so if state name dot equals target, again, I'm assuming there's no null values in this array, but that might be something you want to check for. If the state name equals the target that I'm searching for, well, then what do? This is a Boolean method, so it's going to return true if it's found, false otherwise. As soon as I find it, I can return true because I don't have to keep searching for it. If I go all the way through the loop and I never find it, well, then I can return false because that would indicate the target was never found anywhere in my array. All right, those were some of the basic array algorithms. On the AP exam, you're expected to know a few different algorithms as well. And I'm going to go over some of the more complicated algorithms for arrays here. And I'm going to go over them pretty quickly. So if you want a more detailed breakdown, be sure to check out my unit videos for 4.5 array algorithms that can be found in my Unit 4 playlist. Let's look at the next 3 algorithms, which are going to be determining a minimum or maximum value of all the elements in an array, accessing consecutive pairs of elements in an array, and then determining the presence or absence of duplicate elements in an array. Let's start with the max. So here is an algorithm, no code, just comments, that determines and returns the largest integer in an array called values. Well, what I do first is notice I'm going to say my first value is going to be my initial max. Then I'm going to traverse the array. And if I ever find a value larger in that array, well, then that becomes my new max. And after the loop is finished, I can return whatever my max value is. Here's the code that goes along with that. Notice I sent int max equals values bracket 0. I traverse the array using a for loop. If I ever find a values bracket I that is greater than max, that becomes my new max. And then after the loop is done, I return it. What if I wanted to find the min though instead of the max? Here are the changes to find the smallest int in my values array. Notice it's called find min now, and my values bracket 0 is still used to initialize my minimum value. And then the algorithm looks very similar, except here I'm looking for if I ever find a value that is less than my current min, not greater than, that becomes my new min. And after my loop is finished traversing, I return my min. Let's look at an algorithm that involves comparing consecutive values within my array. Here's a method called isArrayIncreasing, and it returns true if the values in the array are increasing, returns false otherwise. So my algorithm here would be to traverse my array. And if a value is not less than the one after it, well, then I immediately return false because I found a situation where the values in the array are no longer increasing. But if I get all the way through the array and I never find one that is less than the value after it, that means they all must be increasing, so I'm going to return true. Here's the code. So notice I have a for loop that I'm looping through. I'm going to values.length minus 1. And the reason I'm doing that is because look at my if statement. I'm comparing values I and values I plus 1. And if I ever find a situation where values I is not less than values I plus 1, well, then that must mean it's not increasing just for those two. All I need is one occurrence of that. Well, then I immediately return false. But if I get all the way through the loop and I know that all the values are increasing, I'm going to return true. All right, finally in this group, let's look to see if there are any duplicates in an array. So I'm going to return true if there's any duplicates, false otherwise. So how do I determine if there are duplicates? Well, I'm going to traverse the array, and then I want to have another loop to go through all the elements after my current element and check to see if there are any elements that are the same. And if they are, immediately return true because that means I found a duplicate. But if I get all the way through my loops and there are no duplicates, I'm going to return false. Here's the code. So notice I have a for loop. I have my traditional for int I equals 0, I less than values.length, I plus plus. My current value is values bracket I. Now I want to loop through all the elements after the current element. So notice this loop starts int A equals I plus 1. So A is going to represent the index of each value after my current I value. So I'm going to check to see if any elements are the same, if current double equal sign values bracket A, and if they are the same, immediately return true. Then once that loop is done, I'm going to go to the next value, I, which is going to be my new current. And I'm going to keep repeating this process. But if I get all the way through my loops without ever finding a duplicate, I'm going to return false because there are no duplicates. Okay, let's look at 3 more algorithms, the last 3 of this section, that are going to be different variations of some algorithms that you might be expected to write on the AP exam. We're going to look at determining if all elements in the array have a particular property. We're going to shift or rotate our elements to the left or right. And finally, we're going to look at how to reverse the order of the elements in the array. So let's start with this method called all words longer than. I want to see if all the words in my array are longer than a particular length parameter that I have. Notice I have a string array called words that is sent to this method, and I've got a length parameter, which that's going to be I'm using for my threshold to see if all the words if all the strings in words are longer than length. All right, so my algorithm is going to be I'm going to traverse the array, and if I ever find a word that is not longer than length, well then return false immediately because I found something that makes my statement not true, that all the words are not going to be longer than length. But if I loop all the way through and I've never returned false, that means all the words are longer than length, so return true. What's the code look like? Well, it looks like this. I used a for each loop here. and it says for each string current within the array, if there's a word that is not longer than length. Now here, I went ahead and checked to make sure current was not equal to null because I don't know if this array has null values or not. And if the length of current is not greater than length, then I immediately return false. And otherwise, I'm going to return true at the end because all the words match that particular parameter of length or more. Next, I want to shift all the elements in a given array left one position and then put the original first element on the end. So this is involving shifting elements in my array. Here's my algorithm. So I'm going to temporarily store the first element. I'm going to traverse the array, and while I'm in the loop of the array, I'm going to assign the value after my current position to the current position. So this will shift everything down one element or to the left one position. And then finally, when I'm done, I'm going to put the original first element at the end of the array. How would this look in code? Here we go. So notice I store the original first element in a value called temp. I'm going to traverse the array. Again, notice I'm going to values.length minus 1 because I'm going to be using I plus 1 inside this loop here. I'm going to assign the value after my current position to the current position. So values I equals values I plus 1. I copy whatever's in values I plus 1 into values I. I do this for the entire array, and after I'm all done with the traversal, at the very end, I'm going to put the original first element into my last position, values.length minus 1, which is the last position, equals temp. There we go. Let's look at the last one. So here, I wanted to reverse all the elements in the array. And this is actually a very, very short algorithm. I just really need to traverse the first half of the array, and I need to swap the position in element I with the position in length minus I plus 1. And if you go through and think about it, it's going to do the first one with the last one, and the second one with the second to last, and third with the third to last. I go into this a lot more detail in my section 4.5 videos, but let's go ahead and look at the code for this algorithm. So I'm going to loop starting at I equals 0, I less than values.length divided by 2. And then here I'm going to switch the element in position I with the element in position length minus I plus 1. So temp equals values I equals values.length minus I plus 1. And then finally values.length minus I plus 1 is going to equal temp. And that does my swap, and it's in 3 statements that copies one element to the other. And if I do that for half of the array, then all of the elements have been reversed. Hey, time for another multiple choice question from the course and exam description. So here, this is a method called find max value. We just looked at this algorithm. So it says, consider the following method, which is intended to return the maximum integer value contained in ranges. And it has this algorithm here and the code for it. And it says the method does not always work as intended. Which of the following changes can be made so the code works as intended? If you want to pause here and take a look at this, we'll be back and look at the answer in just a moment. Ready? Okay. Well, the answer is A. We want to change line 4 to max equals ranges box 0. Why is that? Because, well, what if all of these values were negative? And then I started off by saying max is equal to 0 on line 4. Well, there'll never be a value greater than 0 if they're all negative, so this isn't always going to work as intended. When doing a max or min value algorithm, it's always recommended that you set your max or min equal to the first element in your array list. That way you're guaranteed to have some value that is going to be your minimum or your maximum, and then you can compare all the other values in the rest of the list to that original value. Okay, let's talk about using text files. So files are storage for data sets that persist or exist when the program is no longer running. And this data in a file can be retrieved while we're running a program. Now, we often call this file input output or just file IO. And we're going to use this file called Hop College's 2022 edit, and it's a CSV file for our program. And we're going to use the file and scanner classes to connect our file to our program and read the data. So here's an example of a data file. I actually got this from Kaggle.com, and I cleaned it a bit because it had a lot of information in that I really didn't need. But you can notice that according to the headings at the top there, we have the rank, the organization name, state, campus heading, etc., of all these universities. And this is from a list that somebody put together that considered the top colleges of 2022. So for these next few moments of slides that we look at, we're going to be looking at using the file class, which is in your Java Quick Reference. And we're also going to look at the scanner class, which is in the Java Quick Reference. Specifically, there's lots of different methods that you can use here, such as next int, next double, next boolean, next line, to read values from a file. In this example, I'm going to be using the hasNext to determine if there are any more lines to read, and then I'm going to use next line to read that line from a file. Now, if it was a file of integers, maybe you use next int. If it was a file of just individual string values, maybe you just use next. But I'm going to be using next line. And then finally, I'm going to close the file at the end by using the close method. Okay, so let's look at an example of how I would read from this text file. So notice I have all my import statements. I'm importing the file class, the scanner class, and I'm also importing the Java IO exception. This is because there's a possibility of an exception being thrown, and we're not going to get into handling. You don't need to worry about exception handling on the AP Computer Science exam, but just note that we're going to include this throws IO exception on any code that is going to be doing file IO. So how do we read from a file? Well, first of all, I'm going to create a file object. I called it college file equals new file, and I sent it the name of my file. Now, the file needs to be in the same folder as your program, but it could be a full path, or you could specify a web address as well. Then notice I create a scanner object called input, and I used the college file as the argument to my constructor for the scanner. Okay, now to read from a file, I'm going to skip the first line. I'm going to say input.next line and not capture the value because I know that's going to be the headers of my file. But now, while there are lines to be read, I'm going to look at input.hasNext. If that comes back true, meaning there are lines to read still, I'm going to use the input.nextLine call and retrieve a line from that file. That's going to give me the entire line. I'm going to store that in a string called info, and then I'm going to print out that line of info. And then after I've read all the lines, I'm going to do an input.close. Let's run this to see what it looks like. So here it is. It just read all of the data, and it printed all the colleges out one by one, all the way down to number 498. And you should be expected on the AP exam to maybe answer questions on the multiple choice section about how the scanner class and how the file class work together in order to retrieve information from a file. Okay, now that I have all this information, I'm going to create a college class, and I'm just going to go over this real quickly just to show that we have these different attributes. There are 16 attributes in this data set. So I'm going to create a class called college, which has 16 instance variables. I'm going to have a constructor to initialize all 16 of those instance variables. And then I'll have 16 accessor methods to get that information. You'll notice them all here. Here are the next 16 accessor methods. And then finally, I'm going to have a toString method. And you should know what a toString method does. A lot of classes have a toString method, so that gives us a string representation of the information contained within that class. In this case, I have a string that appends all 16 of my instance variables together with labels to give us some information about our college object. So how are we going to create these objects from my line of data? Well, let's go back to the Java Quick Reference that we have, and you'll notice the last method of the string class is called the split method. And this is going to return a string array where each element is going to be a substring of the string that I'm calling this method on, and it is going to be split around the given parameter del, which is going to be my delimiter for each of my string objects in the array. Let me show you how this works. So I'm going to have this array called values, which is an array of strings, and I'm going to use my info line that I just read from the data file, and I'm going to call info.split and say comma, because this is a CSV file, which stands for a comma separated values file, and all of the data is based on being separated by these commas. So now I can use those individual elements of the array to construct our college object. One other thing to be careful of here, though, is because the array that we're going to create is all an array of strings, I need to be careful of, wait a minute, some of those data elements are not strings. So I need to convert them to integers or doubles to store properly within my college object. So this is where on the Java quick reference, we can use these integer.parseInt and double.parseDouble. These are static methods that we can call from the integer class and the double class to help us convert strings into ints or doubles. Okay, so now I've got my string info equals next line, and I have my string values equals info.split. And here's where I now have an array of strings called values. But before I can create my college object, I need to make sure that I use integer.parseInt and double.parseDouble on particular values in that array to convert them to ints or doubles, and I can store those in my local variables. Now I can create my local college object. I'm just calling it C, which is a new college object, and I'm going to send it all of the elements to that object. And then finally, I'm going to print each object out in my code. Let's run this and see what it looks like. Here, notice I have the toString method that got called every time I printed out my college object. And you'll notice that it has the information for each institution, the number ranked number 1, number 2, and it's going to go all the way down. Well, that's great. So now I've got these college objects. What am I going to do with them? I need to store them somewhere. This leads us to an array list. What's an array list? Well, an array list is a class in the Java util library, and it's a data structure. It's like an array, but it uses methods to access and manipulate the items in the list rather than our square bracket notation that we just saw with arrays before. Now, another thing about array lists is they're dynamic in size. So the class maintains a value for exactly how many elements are currently being stored in the data structure. And as with arrays, we need to specify the type of objects that we want to store in the array list because all of the data must be of the same type. So let's compare arrays versus array lists. Arrays can contain primitive objects or primitive types or any type of object, but array lists can only contain objects. So if I want to store numerical values like doubles or integers, I'm going to have to use those wrapper classes that we just saw, the capital I integer and capital D double classes. Arrays are a fixed length, whereas we know array lists are dynamic in size based on the number of elements that are currently in the array list. Arrays use square brackets to access individual elements, whereas array lists use individual accessor methods to access the elements at their locations. For assignments, arrays are going to use the equals assignment operator. But array list, we're going to use mutator methods such as add or set in order to put elements into my array list. And finally, arrays use .length to retrieve the fixed length of the array, where array list is going to use .size. So let's talk about how we make these array lists. So here we go, declaring and creating our array list. Here's an example. We're going to have an array list called names, and we're going to use new array list. But notice there's that angle brackets this time, and we have our type specified as to what type of array list or what type of values we're going to store in the array list. We start by saying the array list class, the type of objects that we're going to hold, the name of the array list, the call to the constructor, and the type of objects, again, that we're going to hold. Here I've got an array list of double called numbers equals new array list double. And as I mentioned, we're using the double class since array lists can only hold objects, not primitive types. However, because of auto boxing, we don't need to worry about converting all of our elements, all of our numbers to double objects before we add them in. Java takes care of all that for us. Here, let's look at an example of using the ArrayList class. So I've got this ArrayList tester class, and I have a main method. Here I construct and declare a new array list called myList. This is an array list of strings. I also have an array list of numbers called array list of integer called myNumbers equals new array list of integers. I can create an array list of doubles called decimal values. And if I want to print out the number of elements in the array list, I'm going to use mylist.size. So when I run this, it's going to print out 0. Why? Because I haven't put anything in my array list yet. Okay, let's go back to the Java quick reference. All of the methods for the ArrayList class can be found on this Java quick reference. So things like size, add, both versions of add, either add at a particular location or add at the end of a list. the get, the set, and the remove method. Let's look at how we can use these methods in our code. So I'm going to create a new array list of strings called myList. And when I do that, I now have a reference variable to a list, but the list is empty. So if I add the word the, then I'm going to populate the word the into position 0 of my array list. I'm going to add the word sun, it's in position 1. Add the word rises, it goes to position 2. Add the word east at position 3. And now if I say add 3 position in, what happens here? Now instead of adding at the end, it scoots down east into position 4 and puts the word in at position 3. I can do that again by saying add 4 and put the word the, and now east gets scooted down again and the word the is in position 4. So there's two different ways we can use the add method, two different versions. It's overloaded. We have an add method with one string, or we have an add method with a number and a string so that we can add it at a specific position. And so now we have the sun rises in the east. But what happens if I want to change values? Let's say I say mylist.set2 and I want to change whatever's in position 2 to the word sets. Well, now instead of the word rises, position 2 has the word sets. And then if I change the word at position 5 using the set method to say mylist.set5 west, then east becomes west. And the sun sets in the west. All right, let's talk about the remove method here. So I've added these words into my array list. I rarely study for test. And I want to get rid of the word rarely because that's not really a good idea. And the fact that you're watching these videos say that you study for test a little bit more than rarely. So if I get rid of the word rarely, what do? I say, well, I'm going to say words.remove1. What is that going to do? Well, it removes the word from my array list. Then it scoots everything down to cover up the position that I just removed from. But notice I have string deleted equals. That means that the word that I just removed also gets returned, and I stored it in a string variable called deleted. So now I have two print lines. I'm going to print deleted, and I'm going to print words. Well, words is my array list. Hey, guess what? There's a toString method in the array list class. So now when I run this program, it's going to print out the word rarely because that's the word that I deleted. And the array list now contains the values I study for tests. Fantastic. All right, let's talk about traversing my array list. Just like with arrays, I'm going to use a traditional for loop to say int I equals 0, that's my index, I less than or equal to 5, and then I plus plus. And notice in my print line, I have the statement mylist.getI. So this is going to start at 0, and my index is going to go 0, 1, 2, 3, 4, 5, and visit every element in my list. And when I run this code, it's going to print out the sun sets in the west. Fantastic. What happens, though, if I say I less than or equal to 10? I know there aren't 10 elements in the list, but what happens when I run this program? I'm going to get an index out of bounds exception because I tried to get a value in position 6. This only goes to 5. So it doesn't work. So rather than put a hard-coded number here, I'm going to use mylist.size here because this way I don't have to worry about how many are in there. The mylist.size will always tell me exactly how many elements are currently in my array list. Currently there are 6, so it's going to loop as long as I is less than 6 in this case, and it's going to print out the sun sets in the west with no problem whatsoever. Now let's talk about what happens when I try to do a remove during an array traversal. So here I've got another completely different example. I've got an array list of integers called myNumbers equals new array list of integers. Let's say I populate it. I'm not showing the code for that, but let's say the array list has these values as shown at the bottom here: 12, 42, 17, 92, 38, 8, and 22. I have a for loop for int I equals 0, I less than myNumbers.size using the .size method like we just discussed. And then if myNumbers.getI is greater than 30, I want to myNumbers.removeI. So I'm going to remove any element that is greater than 30 from my array list, and then print the array list again. So let's see what happens when I run this code. Notice there's my original array list, the 12, 42, 17, 92, 38, 8, and 22. And then I have a shortened array list because I removed some numbers, but I didn't remove 38. 42 was removed, 92 was removed, but 38 did not get removed. Why? Well, this is something you have to be careful of when removing from an array list. Let's recap what happened. As I removed 92 when I was equal to 2, 92 got removed. The rest of the list slid down into the missing position where the 92 was, and now 38 was in position 2. Well, after they all slid down one position, I now becomes 3, and now I look at position 3, which contains the 8. So I skipped over the 38. So when writing code that involves removal from an array list, that's something you have to be very cognizant of and be careful to make sure that you don't skip over any values. So how can we fix this? Well, one way would be every time that I remove an element, we can back up our index value one value. So we'll evaluate the new element that got shifted into that deleted element's position. Hey, no more skipping. As I run the code, you'll notice the 38 has now been removed. Another way of handling this as well would be to traverse the array list backwards. Now, every time we remove an element from the array list, the elements that shift left are ones that we've already evaluated. So again, no more skipping. When I run the code, everything works fine. All the numbers that are greater than 30 have been removed. So for the AP exam, remember that if you're going to be removing during a traversal, you have to account so that you don't skip any positions or any elements in the positions that they're being shifted into. Now let's talk a little bit more about array list traversals. Here, I've got another program, an array list of strings called mywords is a new array list of strings. I populate it, the code's not shown, but let's assume it has alpaca, bear, camel, dog, elk, and frog. And again, I'm going to do my traditional for loop, I equals 0, I less than mywords.size. And inside the loop, I'm going to have a string called animal, which is mywords.getI, and then I'm going to print out my animal. So when it runs, it prints what we expect it to. It prints out every single element within my array list. But what if I change this to a for each loop? Well, it should also work, right? For every string animal within my words, print out the animal. It works no problem. But a couple of things that you have to be aware of when using a for each loop or an enhanced for loop with an array list. First, what if I tried to add the word giraffe during my traversal? So I'm printing out my animals and then I try to put the word giraffe, that's going to go at the end after frog. What happens is I get a concurrent modification exception. If you're using a for each loop or an enhanced for loop during a traversal of an array list, you cannot change the size of the array list. It'll give you that error. So be careful, don't change the size of the array list while you're traversing. Likewise, what if I try to remove an element from my array list? Same problem. I can't change the size of the array list during an enhanced for loop traversal, so be careful. What about something like this? What if I change position 2 to be a cat? So now it's alpaca, bear, cat. This is no problem. Now it's changing it over and over again every time I'm looping through, right? But the size of the array list did not change. We just modified an existing element, no problem. All right, let's try another multiple choice question from the CED. Here we go. We had this method revise list, and it's a for loop. It looks like it loops through, it checks some values, and then it does a list.set to change some values. The revise list method is called with an array list containing the values 1, 2, 3, 3, 2, 1. What will be the contents of the array list after executing this method? Go ahead and hit pause if you want to give it a shot, and we'll come back and look at the answer. Okay, here we go. Did you say C? The correct answer is C. Why? What happens here? Let's take a big look at this code. Here is my array list, right, with these values. And if you look at the code from a higher level, if you can figure out, rather than tracing through every single iteration, can you figure out what the code is actually doing? It looks like I'm getting each element of my array list into temp, and then I say if temp rem2 is equal to 1, if the remainder when I divide by 2 is equal to 1, what does that mean? Well, that means I have odd numbers, right? So if temp is an odd number, then what am I going to do? I'm going to change that number, list.set, to be 1 more than temp. So here are my odd numbers, the 1, the 3, the 3, and the 1. So every time I find an odd number, I'm going to set that value to be 1 greater than that current value. So 1 becomes 2, 3 becomes 4, 3 becomes 4, and 1 becomes 2. So as a result, my answer is C. All right, let's keep going. Just like with arrays, we have our array list algorithms as well too. And as we're doing our array list algorithms, This is what you're going to be doing specifically in question 3 on the free response questions of the section of the exam. But you could also have some multiple choice questions that are going to require you to evaluate algorithms or come up with missing pieces to algorithms in the multiple choice questions. Make sure that when you're writing code for ArrayList algorithms, you always think about what is the goal? Are you returning a value or a location or a calculation? What type of result do we want to get? Are there some objects in the array list? What type of objects are they? Can we compare them? Can we check an attribute of them? And do we call methods? And do we always need to traverse the entire array list? Under what conditions could we halt before traversing everything? So for these algorithms, let's revisit the college class. So we talked about this briefly, where we have this college class. I have all these instance variables, all of these accessor methods, more accessor methods, and I'm going to put these into a program. Here, I have a class called institution list, and notice that I have an instance variable called schools that is an array list of colleges. I've got a constructor that is going to initialize my school's instance variable with a brand new array list. And then I have a load data file, which is going to load the data file that we saw earlier in this video into that array list. Let's look at the code for what load data file does. It takes in a string file name. It's going to do all the steps that we saw before about reading from a file. It's going to do an input.next line. And then while it has next, it's going to get all the different lines and it's going to do an info.split. Then it's going to take that array and put all those values into local variables and create a college object called a college. Now, what am I going to do with that college object? I'm going to say schools.add a college. And now my array list is going to be all of the colleges from that list. I created college values and I now put them all into my array list called schools. So now I've got a full array list full of these college objects. And now let's take a look at some array list algorithms. The first 3 that we're going to look at is going to be determining the maximum or minimum value in an array list, computing a sum or average of values in an array list, and determining the elements of an array list that have a particular property. And these are all common algorithms that you would be expected to do, particularly in question number 3, or some variation of these algorithms. So really understanding how these algorithms work are really going to put you in a good position to answer the 3rd free response question. And as I mentioned, also answer any multiple choice questions that deal with algorithmic uses of an array list. Let's talk about finding the minimum or maximum value first. Now, these algorithms for the array list are going to be very similar to what we did with an array. Remember, we're just using a different data structure, right? We're using an array list instead of an arrays. So here, we're going to get the largest student population. We're going to return the college object with the largest total student population. So here's my algorithm. First, I want to check to see if the array list is empty. Then I'm going to assume the first school has the largest population and save it as my largest. I'm then going to loop through all the rest of the schools, check if the current school has a larger population than the one I saved, and if it does, then that school becomes our college with the largest population. After checking all the schools, return the largest. Don't forget, we have an array list of colleges called schools, and there is a method called getTotalStudentPopulation within the college class itself. Okay, let's look at the code for this algorithm. So if the size of the schools is 0, well, I'm going to return null because there is no maximum value, right? So now I'm going to go ahead and get schools.getZero and call that my largest college object. Now I'm going to loop through the remaining schools for int I equals 1, I less than schools.size, and I plus plus. I say I equals 1 because I really don't have to compare it to the first school. I know the first school is currently my largest so far. If the current school has a larger population, meaning if schools.getI.getTotalStudentPop, right, which gives me the population of the current school, if that's larger than my largest .getTotalStudentPop, then schools.getI becomes my new largest college. And then after I looked at all the schools, I'm going to return the largest. Okay, here's another one. Computing a summer average. This one is going to calculate and return the average student to faculty ratio for public schools in a particular region. So this is called get average public student faculty ratio, and my parameter is called region. So what do I want to do here? Well, I want to loop through all the schools. I want to check and verify if the school is public and if it's in a particular region based on the parameter. I'm going to add that total ratios and the number of schools, keep track of all those. And then I'm going to avoid division by 0 and return the average. So let's think at the code of what this is going to look like for computing a summer average. Don't forget that we do have our array list of colleges called schools, and then these three methods, which are probably going to come in handy. I'm going to need the get college type, which returns whether it's a public or some other type of institution, the get region, which tells me what region the college is located in, and the get student faculty ratio, which will give me the student faculty ratio that I'm trying to get the average of. All right, here's the code. So I've got my two values, a total and a count. My total equals 0, my count also equals 0. I'm going to loop through all the schools. Here I'm using a for each or an enhanced for loop. So for each college C within schools, I'm going to check to see if the school is public and if it's in the region by saying c.getCollegeType to see if it equals public and to see if the region c.getRegion dot equals my region parameter. If those are both true, then I'm going to add the student faculty ratio, c.getStudentFaculty ratio to my total, but I'm also going to increment my count because I want to keep track of how many of these colleges that I found. After the loop is done, I first want to make sure that I found some. So if count is still 0, I'm just going to return 0. That way I can avoid dividing by 0. But if it's not 0, I'm going to return total divided by count, and that will return the average student faculty ratio at these public institutions in the particular region. Okay, and now finally, the last one in this grouping, we're going to determine the elements in an array list that have a particular property. Here, we're going to return an array list of all colleges that are located in a particular state. So I've got a method called getStateSchools. Now notice this one has a state parameter and it returns an array list of colleges. So one of the first things we have to do, according to the algorithm here, is create a brand new array list for these state colleges. In order to return an array list of colleges, I need to create an array list of colleges. So I'm going to loop through the original list of colleges, check if a college is located in a particular state, matching the parameter. If it is, I add it to my new array list. And then after the loop is done, we're going to return the array list. Don't forget, we have an array list of colleges called schools, and there is a getState method in the college class. All right, let's look at the code. You would go first by creating a new array list. We're going to call this state list. So it's an array list of colleges called state list equals new array list. I'm going to loop through the original list of colleges that's called schools. So int I equals 0, I less than schools.size, I plus plus. If schools.getI, which gives me the college, .getState gives me the state that I'm in, dot equals, if it's equivalent to the state parameter, well, then I found one. So I'm going to add it to my state list. How? By saying statelist.add schools.getI. And then finally, after the loop is done, I'm going to return state list. Finally, let's look at 3 more array list algorithms. Now, I realize I'm going through these array list algorithms fairly quickly. So if you want to get a more detailed breakdown of all the code and how these algorithms work, I do have a video in section 4.10 of my Unit 4 playlist, which really goes into a lot of detail of these particular array list algorithms. All right, the last 3 that we're going to look at. Let's determine the number of elements in an array list that have a particular property. Let's access all consecutive pairs of elements in an array list. And then let's determine the presence or absence of duplicate elements in an array list. And again, you want to be familiar with these types of algorithms so that you can write the algorithms as required for the free response question number 3 and also answering questions about array list on the multiple choice section of the AP exam. Okay, so our first one is going to be, let's determine the number of elements in an array list that has a particular property. In this case, let's count and return the number of schools where the number of students receiving financial aid is greater than a particular threshold. So what am I going to do? Well, I'm going to loop through all the schools. I want to check to see if the percent of students receiving financial aid is greater than a threshold. And if it is, I'm going to add it to some sort of counter. So I'm going to need a counter as well. And then at the end, I'm going to return my counter. Let's see how the code works. Don't forget, we have an array list of schools, array list of colleges called schools, and we do have a method called get percent of students financial aid. This tells me how many students or what percentage of students are receiving financial aid at this college. Okay, here's the code. So I start off with a counter. I'm going to need a counter, and I'm going to set it equal to 0. I'm going to loop through all the schools using my for each or enhanced for loop again. So for each college with C within schools, I'm going to check if the percent of the students receiving financial aid is greater than my threshold. So if C dot get percent of students fin aid is greater than threshold, well, add it to my counter. So I found another one. After the loop is done, I'm going to return count because that indicates how many colleges I found that had that particular property. How about this one? Let's access all consecutive pairs of elements in an array list. So in this case, I'm going to return true if the schools are in increasing order by rank. So remember, one of the values in each element of my college was the ranking that each school had. So I'm going to loop through the list and compare adjacent ranks. Now they should be in order, but this is a way of testing to make sure that my data is sorted properly. If the current rank is ever greater than the next rank, well, that means they're not in order. So I'm going to immediately return false. And then after the loop, if I never return false, I'm going to return true. Don't forget, there's an array list of colleges called schools, and I'm going to use the college method getRank in order to find out what the rank is for each college. Okay, here's my code. So I'm going to loop through the list to compare adjacent ranks. Now, when comparing adjacent elements and traversing, look that I'm using schools.size -1 in my for loop because I know in my if statement, I'm going to use get I and get I plus 1, and I don't want to go out of bounds, so be careful. So check to see if the current rank is ever greater than the next rank. If schools.getI.getRank is ever greater than schools.getI plus 1.getRank, well, then immediately return false because that means my schools are out of order. And then after the loop, if we never return false, I'm going to return true. Okay, one more. Let's determine the presence or absence of duplicate elements in the array list. I'm going to return true if any two colleges in the list have the same organization name. They should be unique, but this is a way again of checking my data. So I'm going to loop and to compare each school with every other school in the list. Remember we did this before with arrays. We're going to need 2 sets of loops. If 2 schools have the same organization name, we'll then return true immediately. I found a duplicate. And after the loop, if we never return true, I'm going to return false because that means there's no duplicates in the list. We have our array list called schools, and we have a method called getOrganizationName found in the college class. Okay, here's the code. Here we go. So this says we're going to loop to compare each school with every other school. So I have an int I equals 0, I less than schools.size, I plus plus, and then I have another loop, j equals I plus 1, j less than schools.size. So j is going to start after wherever my current I location is. So now I'm going to check if 2 schools have the same organization name, and this is a mouthful. So if schools.getI.getOrganizationName dot equals, and now I'm going to check everyone after it using the j index, schools.getj.getOrganizationName. If I ever find 2 that match, immediately return true because I found a duplicate. And after the loop, I'm going to return false because that means I never return true. All right, that's our array list algorithms. Hey, here's our last sample multiple choice question from the CED. Let's take a minute and look over this. This one has to deal with array list and read it from a file. So it says a text file named roster.txt has the following contents. Assume that file contains no spaces. So we have this Cohen-Isabel, Lee-Cindy, Patel-Anisha, and Sanchez-Michael. And in the following code segment, a valid scanner object named scan has been created to read from the text file. Notice we have our file object called myText equals new file roster.txt, just like we looked at. Scanner scan equals new scanner myText. We sent it the file object. And then I have a string, an array list of strings called usernames equals new array list of strings. And we're missing some code. And the missing code is supposed to assign I Cohen, C Lee, A Patel, and M Sanchez to usernames. So we want to know which of the following answers can replace missing code so that this code segment works as intended. It looks like we want the first initial of the second part of the name concatenated with the entire first part of the name. So it looks like it's a first initial last name type of username. Which of these code segments, and they all use the while scan.hasNext, can appropriately assign those names to my username array list? Why don't you hit pause, check this out, and see if you can come up with the right answer. Ready? Okay, here we go. Well, the answer is C. So what this does is while scan.hasNext, so while there are names left in the file, it creates an array of strings called temp using the split method. So it does scan.next, which actually reads in the entire string, and then it immediately calls the split method using the hyphen as my delimiter between the two strings. That gives me an array of strings, and it's going to be of size of length 2, right? Because the first part of the name is going to be in position 0. The second part of the name is going to be in position 1. So now what do we want to add to usernames? Usernames.add, and we want to add the first letter of the second part of the name. So add temp bracket 1 dot substring 01. That gets me the I in Isabella, the C in Cindy, the A in Anisha, and the M in Michael, plus temp bracket 0. Temp bracket 0, that's going to be Cohen, Lee, Patel, or Sanchez, correct? And that add them together. That gives us our username, and it adds it to the username list. How'd you do? All right. Well, that concludes the first part of our crash course into Unit 4, which is data collections. We covered a lot. We covered looking at data files. We covered arrays and algorithms using arrays. We covered reading from text files. And we also covered ArrayList and looking at all the different types of algorithms that you can do with ArrayList as well. That does it for today. We'll look at the second half of Unit 4 in our next video. Don't forget to hit the like button, subscribe to my channel, and thank you for joining us. We'll see you next time. Take care.